The whole point of sharding is balance. But what if that balance breaks? We created multiple shards thinking that no single shard will be overloaded. But what happens when a single shard starts getting most of the requests? It becomes a data hotspot problem. This will slow down the data retrieval process, which kind of defeats the whole purpose of data sharding. We may not be able to completely eliminate this issue, but we should be able to minimize it as much as possible. The most effective way to do that is selecting an optimal sharding key. A good sharding key will result in even data distribution. So when choosing a sharding key, we must consider few things. The first one is cardinality. Cardinality means how many different values a sharding key column can have. Cardinality of the sharding key will decide how many shards you can create to divide the data. Let's say we have decided to make this active column as a sharding key. This column can have only two values, either yes or no. So its cardinality is 2, which means we can only create two shards if we select this column as a sharding key. One shard will have all the data with active value as yes and second shard with active value as no. The bottom line is the more unique values our sharding key has, the more shards we can create. That will lead to the better data distribution. Another factor to consider is frequency. Frequency means how often a certain value appear in your data. Let's say you are building a fitness application and you decided to shard the database based on age attribute. That means data for people aged between 15 to 30 will go into shard A, 30 to 45 will go into shard B, and 45 plus will go into shard C. On a fitness website, most users are probably between 30 and 45 years old. That means shard B gets overloaded with most of the users, while shard A and shard C stays mostly empty. This creates a data hotspot at shard B. That means shard B do most of the work. Instead of using age alone as a sharding key, we should choose a more evenly distributed or a composite sharding key. Select an attribute that has more uniform distribution across all values. Or even better approach would be to use a hash-based sharding. Apply a hash function to the user ID or email and mod it with the number of shards. This ensures more even distribution and avoid hotspots. If you still want to include age for a specific use case, combine it with other attributes. For example, select age, region, and user ID, and on top of that, apply hash-based sharding to combine these attributes. This helps in distributing users more evenly while still preserving the business logic behind age factor. So the bottom line is frequency of the sharding key does matter and should be considered to avoid data hotspots. Another important factor to consider is monotonic change in sharding key values. Now this is very interesting point. So what exactly is monotonic change in sharding? It means the value of sharding key always moves in a single direction. Either it is increasing or it is decreasing over the time. In sharding, this is a problem because it causes new data to always go to the same shard, which again creates an imbalance. Let's understand this with a simple example. Imagine you are building a database for a school to store student homework. Each homework submission gets a number. So first homework is submission number 1, second homework is submission number 2, and so on. So the submission number keeps increasing and it never goes backward. Let's say you split the database into 3 shards based on submission number, which is your sharding key. In this, submission 1 to 1000 will go to shard A, submissions 1001 to 2000 will go to shard B, and submissions with number greater than 2000 will go to shard C. At the beginning, submissions are new, so it goes to shard A and B. But as the time goes on, students keep submitting homework daily, and the submission number keeps on increasing. That means all the new submissions now will go to shard C, and eventually shard A is never used again, shard B is also done, and shard C keeps getting all the new data. This causes shard C to become overloaded and system slows down because only one shard is doing all the work. With this, we lose the benefit of sharding. Sharding is meant to split the data and work evenly across multiple databases. But when you use a sharding key that keeps increasing, like submission number or a timestamp, all new writes go to just one shard. Other shards are underused. You get a data hotspot which leads to the performance issue. Here are some ways to prevent this problem. First of all, don't use monotonic attribute directly as a sharding key. So avoid using things like auto increment IDs or timestamps as as shard keys without extra logic. So instead of splitting based on ranges, we can use hash of the submission number. This divides the submission evenly across all shards. Now, even if the submission number keeps increasing, when we apply the hash based approach, all the three shards will get the even data. Here is a question for you. Can you think of some other ways to minimize this issue impact? Please comment your answer. So with this, we have completed the database sharding. To understand the fundamentals of sharding, you can go and watch the previous video in the playlist. Now, just to summarize everything in the end, sharding isn't just a database technique, it's a strategy. It's the difference between building a system that crumbles under pressure and the one that powers through your Black Friday sale. Whether it is vertical, horizontal, directory based, or geo based sharding, the goal is the same. Make your data scale as smartly as your application does. And as you scale your platform, always remember, don't wait for performance issues to remind you about your database. And sharding isn't an afterthought. It's a design choice that shaped the future of your architecture. Thank you so much for sticking around till the end. And if this helps clarify your doubts or give you new insights, don't forget to like, share, and drop your thoughts or questions in the comment section. I'll see you in the next video. Till then, let's keep learning.